Hello, welcome to School's Not Out, your daily classroom for CSEC and CAPE students. Today we'll be looking at databases and problem solving, and I am certain that you'll be, of course, getting more of an appreciation to see the importance of these tools. I know that sometimes the concepts seem abstract, but after today, I'm sure you'll be getting, to feel it out, to really get an understanding as to what databases are, what problem solving is, and of course, we'll have a lot of fun. Even though we'll focus on these two topics, we're going to link them and use these links to other sections of the syllabus. So you will get some information about information processing, data security, etc. But keep your wits about you, and you'll be just fine. If you recall the plight that Facebook found themselves in for sharing and selling its users' data, then some questions should immediately pop up into your mind. Well, some did, in my mind. How on earth did Facebook store all this information? Where did they store it? And why did they use it the way they did? The fact is, information is a commodity, and the storage, analysis, and usage of this information is like someone finding a gold mine. Well, in fact, Facebook did. This ordeal led all big IT businesses to reconsider their end-user policies. You know those long terms of agreement that you are asked to read before you use the service? You might have seen the term EULA, which stands for, end user, but guess what? You text it into the Twitter page, all right? Check it out. Go ahead, and the first thing that we need to answer, or the first thing that we need to give a shout out to, we'll give a shout out to anyone who can answer that question. Truth be told, each and every bit of information that we use is being stored in databases. Every mouse click in a browser or a URL request is being stored or recorded by your internet service provider or by the server that issued the website. Every piece of information sent via WhatsApp or any other social media has to be stored somewhere, and that is where databases come in. Most of the times, this is good. Most of the information helps us to do our daily routine and helps businesses to strategize for their customers. But it also means that we should be very careful about the information that we share. Let's look at database as it relates to data warehouses. These big businesses need to store more information than we could ever store for our personal usage. How would a large business store information for over 1 million customers? I assure you, databases such as Access are pretty good pieces of software. But for multinational and corporations and financial institutions whose storage needs are greater than ours and security protocols are immensely integral, then Access may not be the best piece of software to use. Large businesses tend to use tools such as MySQL Server and Microsoft SQL Server. These tools are used in a manner that allow for storage of terabytes upon terabytes of data, and their usage may surpass the idea of them just being database engines. Truly, this is more than information that we could ever use. And for varying types of information that we have, or we need to store, or the businesses need to store, based on that usage and the amount of information that we need to use, we have to classify them as data warehouses and data marts. The principles of storing the information, however, are similar to those that we can apply to our simple databases. And of course, that is what we're going to look at today. Here are some things that you should already know or already be acquainted with. If you aren't sure about these definitions, you may browse the syllabus. It contains a wealth of information on each topic. Now remember, the syllabus is on the CSEC website, and there it is for free download. You should already have a copy on your mobile device for quick referencing. When you're reviewing your notes, make sure you have your syllabus with you. Okay, Bob, the first tip of the day. Okay, I know it doesn't seem like much, but hear me out. For the past couple of years, CXC has made a number of changes to help students cover the breadth of the subject matter instead of just deeply jumping into one subject area. The result of that kind of move means that changes have to take place to improve the kinds of questions being asked. The emphasis now is on your ability to apply the information presented to you by the syllabus. What this means is that you are expected to show a higher order thinking. Application of this information is paramount. This means that you need to know the content sufficiently enough before entering the examination. If you do not know it, you cannot apply it. Just know the thing. Straight. As we continue with databases, here's a simple example of a student table. In this case, the fields include first name, last name, address, city. Of course, as we look at it, you can already see that we can identify the records, we can identify the fields. And in this case, first name and last name are two different fields. I know that some of you might have already decided that, this doesn't make sense. But the truth of the matter is, in a real world scenario, first name is going to be different from last name. And if you check carefully, each one is singular. Now, according to database principles in CAPE, this is what we call breaking the thing down into different compartments and the rule of atomicity. Each field storing just one piece of data. You'll notice also that we have address, and address only takes into consideration the street number and the street name. And then finally we have a field called city and then age. Now these fields, though singular, we can always do what is called a query and put the fields together as is needed. Now remember, we need to keep the fields singular and store information as is necessary for the field itself. There are a couple of things that we could say that are missing, and we're going to look at one of them just now. Here we are at slide 8, and you'll notice that we have decided now to add a student ID by the name of STID. And this STID is a very specific and unique number to each student. Mind you, we only have 2 records in this, and so therefore we can always go ahead to add more records. But if we have a unique number, that unique number serves us in a way that we can identify each student separately. And of course, in this case, Mary Kate Olson has an ID number of 2201918. And her date of birth, you can already see, is March the 23rd, 2007. Now, this idea of a primary key is not uncommon. And let me just show you what we're talking about. As I move on to the next slide, you might be asking, what could this next slide refer to? And we're talking about the use of phones. Now, your phone has a specific phone number, and that specific phone number registers it on a network. This mobile network that we have, Digicel, Lime, whatever it may be, takes this number from the SIM, and this SIM card is programmed or reprogrammed with that phone number. But let me just jump onto a couple of other numbers that you might not have known about. Here we have a picture of 3 other numbers. 3 other numbers other than the phone number. Do you notice them? Well, you should notice the IP address. This number is given to your phone as soon as it latches onto a router. And as soon as you get some kind of information from a network, this IP address focuses on you actually getting every kind of information from that network as is possible. The next number is your Wi-Fi MAC address. And this Wi-Fi MAC address is a physical specification on your device that does not change. And so if you're on a network, the router is going to associate your IP address with this MAC address. The other number that we need to look at is your IMEI number. Now this is truly the primary key. This IMEI number is a number that is registered or burnt into every mobile device. And so this mobile device comes on a network, and immediately the mobile device is recognized by the network. Every mobile device should have an IMEI number. This number helps to track the device. And of course, if you can't track the device, you have to mind where you do upon it. Your company might know what's going on. Just a thought. Unlike the IP address, the phone number, this will never change. And these numbers are unique and serve the purpose of identifiers. So remember, they are primary keys, and that is how they relate to database. Even more closely, God has created us with our own kind of unique identifiers. Can you guess what those identifiers are? Well, if you said, what are fingerprints or voice timbre, then add some strawberries to your ice cream. No two individuals on the planet have the same set of fingerprints or the same voice timbre, no matter how close they are to matching. This is why securing devices and rooms with biometric verification devices is a smart idea. These biometric devices are linked to databases which store fingerprints, voice timbre, and iris patterns, which ultimately form the digital identity of the individual. These kinds of biometric identification serves as a means of securing several rooms in which sensitive information is stored. And this makes them pretty secure. Well, as long as Jack doesn't hijack your iris. You get what I mean? So let's move on. These objects should already be familiar to you. This is a clip from Microsoft Access. If your school uses another software, then you may know the table just by the information placed in it. You should already notice a number of things. The STID is the number that identifies a student. And notice that the data type is a number because we have made it so. Not that it cannot be any other type, even though it is assumed that this student ID is a number data type. If we wanted us to use letters, per se, in the identification number, then we could, but the data type would have to change to text. Whether we are using spreadsheets or databases, the purpose of assigning the data type of any value to a number is that ultimately the numbers will be used in calculations. If there are no calculations to be done, then text may be used. Note that it is also right aligned, which is the common case with numbers in any usage. This alignment tends to be a signal of the possible data types of the field. Note that the first name and last name are left aligned and DOB is right aligned. According to this slide, there are 3 data types. And these 3 data types are the examples that we intend to use. As you learn about these various data types, you will know that it is important to ensure that all the information being placed in a field of any instance is accurate in every regard. Here's a question to help you think about it. What would happen if we entered HTR12342 as a student ID? Try to figure that out. Give up? Well, put it this way. From one data type is used for student identification is a number, or once that is used as a number, or we've stipulated that it's a number, then putting HTR 12342 already violates the data type because HTR is not a number. So when entering data, you have to pay attention to the data of the field in which the data is being entered. The data should both be valid and verified or verifiable. So with any form of data you're entering, you must ensure that every piece of it is valid, meaning it passes a number of validation tests, such as data type tests or such as range test. We must also ensure that the data is verified or at least verifiable. This simply means that the data can be proven to be right or true. So let's move back onto databases. Since as we scratch the surfaces, let's quickly jump into the database topic that we talked about. We will quickly take a look at the types of queries, the simple select queries, and calculated fields. Here is something that you should already know. There are 4 main types of queries that you should already know, of course. And these are select, append, update, and delete. There are other forms of queries, but these are the only ones that you need to be concerned about right now. There's a possibility that you will not be asked what these types are since, as we stated before, CSEC doesn't ask direct questions anymore. This means that knowing the definitions will not necessarily be enough, but not knowing what they do will place you at a great disadvantage. This is not a position you want to be in while you're completing your paper. So with that said, make sure that you know the queries, how they work, what they can be used for, and how to manipulate them to get exactly what you want. We're going to look at our very first query. And this query has to do with a simple like keyword. So while I was attending university, we spent or had a lot of emphasis on applying the knowledge to practical examples. And this is where we begin. We'll use a practical example to demonstrate what we intend to find out or accomplish during this session. Here are the objectives of the session. Now remember, these are simple examples and are the basis upon which you will be able to answer more complex questions during your examination. So use this as a platform to further your knowledge about the matter. Ready? All right, let's go. Our first query takes us to the place where we are extracting information from each table or from this particular table. And it's not exactly specific about the criterion. Just to let you know that this is very simple again. But the impact of such a query would be seen if we had much more information in the table. In this case, we want to identify the students with the first names that begin with the letter J. In our table, we have only one record which meets that criterion. But, of course, the good thing about it is that databases can allow you to do a number of searches at an instant. And it doesn't take a lot of time. Think of it as like Googling something or Googling information. At the instant you type your search word, a search has begun already. And depending on your internet speed, the web server and the search engine, it will return a number of hits from the web. Searching the database is very similar to that process. So with this example, we are not being specific as to why we want to know this information. That can come later. The key is to understand why we approach the query in this manner and why we have this kind of a syntax for this query. Here we can only see that we are only one record we have in the information, one record, because we only had two records in the first place. But let us quickly look at the query from the design view. I'm sure you're familiar with this. Of course, we would have addressed the student table, or we'd have to add the student table because it contains the information that we want. For example, if we want the first name and of course the date of birth, the figure on the left, of course, shows the table which is added. And the figure on the right shows the table or the grid for the query. Pay close attention to it. What have you noticed? Yes, we have one criterion. And yes, I said criterion again. Focusing on the criterion would help us to even more notice or more understand what's going on with the query. Notice under the first name, or under the field, we have placed the text like J asterisk. And it is important that we understand why we have it J asterisk. What we want to find is a particular set of records based on a partial match. A partial match. And the partial match will therefore depend on what comes after the first letter and what comes after like. In this case, we have J asterisks. And this simply means that J must begin the first name of all the records we want to find. Whatever comes after the J is not going to be our concern. We just want to find what fields or what first name starts with J. The engine, of course, recognizes the asterisk as a wildcard. And this wildcard pretty much emphasizes that anything else can come after, no matter how long. I'm sure you are acquainted with other wildcards. You might have used them from before. And if you can figure out one wildcard, text it in. Text it into Twitter. Let TVJ know that you're watching. All right? Text it in. Let's move on to the next query. This query in particular employs the use of a criterion row under the field containing the student's date of birth. The simple query tries to select the persons born September or born after September 1st, 2007. Special note must be made that the use of the greater than sign and the hashtags that surround the date is how this query should be written. If we read the section of the query containing the criterion, it could be read simply as DOB greater than September 1st, 2007. Now note, the time format being used is of an American standard because that is what I have chosen and that is what my computer is on. If you're in the examination and another format is used, go ahead and use that format. We are going to, of course, move on to a third query. And this query has what is called a calculated field. This calculated field is pretty important and tends to come in a lot of exams. As can be seen, we are looking at a figure at the top of our screen with a formula. And the information we want to extract has to do with students who are owing. Now, let's just pay attention quickly to what's on our screen. We have selected first name, last name, fees paid, and owing. We've decided to add a second table to our query because we wanted to store the fees paid for the students in another table. And with these two tables, we want to join them. And we join them during the query. We join them during the query so that we can get information from both tables. Notice that we've made a link with the primary key of student ID and student ID or STID in fees. And when we now move on to our actual calculated query, we are looking at the function or the formula that we've created. The name of the query is owing, but the name of the field is also owing. And this query or this query field has two sides to it. The name of the field separated by a semicolon and then the actual calculation. This calculation here represents the usage of numbers and fields inside of the query. Let's say, as we have here, the school fee was 5,000. Then what we do is to minus whatever the student paid from that 5,000. And this is a simple mathematical formula. As you can see, because we're using a field from the table, we have to enclose that field into square brackets. Not parentheses now, square brackets. And of course, our result will be this particular table. We have the first name, last name, we have the fee paid by the student, and then we see where owing is showing the difference. Make sure that you are accustomed and acquainted with these calculations because they may come in any form. Let's take another look at the formula itself. What did we just do? Well, we looked at fields, we looked at data types, we looked at primary keys, types of queries, etc. And we looked at the keyword like wildcards, and all those are acquainted with databases. But we also made some segues, and make sure that you are acquainted with these as well. They are coming on your exam. Data and internet security, mobile networks, IP addresses, data validation and verification. Please know these for your exam. They are integral. If the exams don't come, then make sure you know them for future because they have real world applications. And now we go on to deal with what some may consider to be the most disgusting part of the syllabus, problem solving. As a matter of fact, I love it. I don't know how, nobody don't love it. I'm a programmer. Go you, tech bulldogs. Well, I mean, bulldogs, yeah. So here we are now, the part of the syllabus where all of us think it's a problem. Most of us think that we can't do it and it's hard. But the fact is, if we keep our wits about us, it's pretty simple. And we're going to go through what it means for us to write pseudocode and the problem solving. Don't worry, we're good. Here is one question that one of my students conjured up, and yes, I said conjured up, while doing her revision for CSEC. And Jana of 5L, if you're listening, big up yourself. Sorry, let's get back to the programming. This program should display whether students of 5L receive iPhone 11s really, for attaining only 1s and 2s in their subjects on the upcoming CSEC examination. Whoo, that hard. I'm kidding. No, it's not hard. But she is a pretty intelligent girl, if you understand what I mean. All right, so let's push to making sure that we trim down Jana's program. Here's my derivative. This program should display whether students of 5L receive iPhone 11s for attaining 8 or more grade 1s in the upcoming CSEC examination. This is a little better. All right? So here's what we want to see, or here's what we want to break down. This is my breakdown, of course. We need to know the amount of grade 1s, and we need to know the student or the student's name. We need to know how many grade 1s and the student's name. Let me repeat, how many and the student's name. The only rule, as we can see, is that they have to have 8 or more subjects in order to get the iPhone. With that said, let's look at 5 tools used in problem solving to dissect a problem. Yeah, man, let me go. All right, so if your answers resemble this, congratulate yourself and add a scoop of chocolate sundae to your ice cream. The IPO chart, truth tables, pseudocode and flow charts, trace tables. Those are 5 of the tools. Of course, there may be others, but, of course, we're only looking at these 5. And we might only get to touch about 2 or 3 of them. The first one is the IPO chart. And this is my makeshift IPO chart. Your teacher might have given you different ways to put it into your IPO chart, and that's fine. You can use variables, but what is true about the IPO chart is that it helps you to break down your information. It helps you to bring it to the place where you can better understand what the inputs are, what the outputs are. So in my table, I have under input student name, grades, grade 1s, full stop. That's fine, that's good. At the output, I want a message, and so that is why I have iPhone recipient message or not. So that is my printout. The processing, of course, is a little bit more technical, but what you want to do is to make sure that you put all your calculations here. I just simply put the condition here, grade 1s greater than or equal to 8. You can add more if you want, or you can add more based on the question that you're answering. Next is my truth table. You should already be acquainted with this as well. But as I said before, I only have one rule, and that rule is grade 1s greater than or equal to 8. And it's simply this. You get the grade 1s, or you get the amount of grade 1s, then you get the iPhone. If you don't get it, don't get the iPhone. But we can expand on our question if we wanted to. Here's how. Let's say that the student had to have a good behavior, or to have good behavior, and they had to have the amount of grade 1s. Here's what our table would look like. So in this case, we want to ensure that we have both conditions in our table as well as the outcome. But the condition is that if the student gets grade 1s or gets the amount of grade 1s and has good behavior, then the iPhone is a must. Notice also that we are looking at the other conditions. If the person does not get the amount of grade 1s, which is 8 or more, don't have no good behavior, no phone. If they get the grade 1 and no good behavior, no. If they don't have the grade 1s and they're having good behavior, still no. So the point is that this yes at the bottom more or less shows us what is called a conjunction or an AND operation. So both conditions have to be satisfied in order for the student to get the iPhone. And for those of you who are logophiles among us, the word conjunction comes from the word conjoin, which means to combine. And of course, that's an English insert. Let's move on with IT. So now the pseudocode. And we only have a little time left, so let's hurry. We already know what pseudocodes are. We already understand what they do. But to recap, a pseudocode is a simple statement or set of statements to help to ensure that you have the logic of your solution correct. The best thing to do with your pseudocode, or I tell my students, whenever you're writing or doing your pseudocode, the first thing to do is to sit and write out the code as if you were writing an essay. How would you solve the problem? Just write it like an essay. And then when that is done, we would definitely break it down into things that look like program code. I also have students who decide that they're just going to jump to the program code itself. And we have a name for them. And if they are listening, hello, code and fixers. But what they tend to do is to jump to the program code because it seems fast and the results seem to come. But what will happen when you just jump to the program code is that you'll be having a number of unforeseen logic errors, which you have to fix. So the best thing to do is to write it out like an essay, then go into the pseudocode. Let's look at the pseudocode that I decided to write. Now, of course, as a teacher, I know when students are cheating. One pseudocode cannot resemble another one exactly. And I know that some of you might decide that you want to share information. No, write it yourself. Learn how to do it yourself. This is my code. But if you wanted to write another code on your own, your code would not exactly look like mine. There will be a number of differences. And let us look at some of the differences that I've shown. First and foremost, your pseudocode has to have a start and a stop. For those of you who have completed the SBA, you would have noticed that the start and stop in your pseudocode might be given a mark of 1. Then I have what is called an initialization. And this initialization has my variables being given a starting value, and that's what initialization stands for. I'm giving them a starting value. Some of you might find where your teachers would have given you the name of the variable type or data type, or student name might have an arrow beside it and it would say string or whatever the case is. That too is fine. Why I do it this way is because when I initialize student name with all those A's, that tells me that it is already a string, but I also have a value inside of it that I can start with. All right? Grade 1s is initialized to 0, and you know why. That's an integer. Then I have the user prompt, and I have the input statements that come after, which you should already know. And then here comes my if statement. What I've noticed in many practices, or many times that the students have tried to practice their pseudocode, is that they forget to put these little statements as in if, else, and if. You have to put these in. That delimits what statements are in your if statement. And notice also I have a number of spaces and line spaces throughout my program and throughout my pseudocode, and this is what we call white spaces generally, and that ensures legibility of your program, and you get a mark for that. All right, so keep that in mind as well. So you want to keep your pseudocode, even though you want to keep it tight, put in your white spaces, put in your space so that it's legible, and that is what is most important. So this is just for one person, and if you notice, I'm not even looking at the entire class. I'm just looking at one person, giving one person an iPhone. One person. And now we're going to move on to just adding another piece of code that would allow you to do it for several persons, even though that might be an undetermined amount of persons. Here is the final adjustment. I've decided to use what is called a repeat until loop. And notice they are in red. So just jump to those sections quickly. We have a repeat at the top that encompasses the entire code, and then at the bottom of the if we have an until statement. This until statement has two conditions separated by the or operator, which means that any one of these conditions pops up during our code, then we will end the entire program or the entire pseudocode. Let's look at it carefully. Repeat, then we start to print, and notice I've changed the print statement. It now says, please enter name of student and number of grade 1s attained. Enter -1 for grade 1s or word end for student's name to end. Let's look at what it was before. Please enter the name of student and the number of grade 1s attained. So we have changed that code. And if we also look at the bottom here, everything is indented inside the repeat until, which means that it is inside this repeat until statement. I've seen a number of codes that students decide that they're not indenting anything, and of course that is a subtraction right there. After marking for about 5 or 6 years, I've seen several codes looking like this. And part of the problem is that when we are going through the code and trying to read through it, we don't know where you're ending and what you're starting, where you're starting. So we have to be deciphering these things. And it's best that you indent so that we can read it through. It's also important that when you get to your actual Pascal code, you do the same kind of indentation. The fact of the matter is, IT is not really hard. I think the most problems that students find with it is that they have not been able to apply the knowledge right across. They love the tools, but they can't apply the knowledge. And so you might find that a student is in love with what the computer can do. They're in love with gaming, but they're not really interested in how it does what it does. I was interested in how it does what it does, and that is why I love programming. And so when I teach you about programming, I'm teaching you how to think logically. The problem is not the programming, it's how you thought about solving the problem. So when you're ready to solve the problem, when you're ready to understand how to solve the problem, you're ready to get started with programming. Part of the problem has always been that as you get the problem, you don't know how to break it down. You don't know how to bring it to its smallest elements. And that is where we talk about IPO chart. That is why we talk about truth tables. That is why we talk about trace tables. Breaking your problem down so that you can understand what's going on with the problem. And that way, you can write a good pseudocode. You can write a good program. As we're ending, let me just jump into some very simple problems that we normally find ourselves into. And let me erase the board quite quickly. And this is a joke that my friends my students tend to make a big deal about. One of the biggest problems they have always done is leave the semicolon off. This thing that ends a program or ends a line, they tend to always leave it off. And one day I was in a class and I said to myself that this is going to be a big joke. And they said to me, "Sir, why we have to use semicolon?" And I'm saying, it's just like a full stop in English. It's just like a full stop in English. And so you have to pay attention to the syntax. Guess what one of them said to me? "Sir, what if somebody was flying a plane and needed to write a program about flying a plane? Or even worse, wrote a program that ran the plane or that governed the plane operations, and the programmer left off a semicolon?" If the programmer left out a semicolon, then we are down in the ditch. We are heading for sea. And they started laughing, and I'm like, "Why are you laughing?" They said, "Sir, can you imagine the pilot saying, 'Oh, we are going down, Mayday, Mayday, this is flight 741, we are going down, Mayday, Mayday.' It looks like the programmer left off a semicolon." Don't leave off your semicolons, boss. Don't left them off. Just like English, they tell you when you're ending. Also, don't forget, write through your programs. Do them over and over. If you don't get them right the first time, do it again. That's what Jana did with me. I didn't sleep last night because I had to help Jana fix. Write again and again and see how it works.